Weather Group. This is the Wednesday, November 8th, 2017 edition of our little weather get-together every week. This is the episode about the Joint Polar Satellite System, JPSS-1. And tonight we have Dr. Mitch Goldberg on with us. He is the NOAA Chief Scientist and will be live on the launch site as JPSS-1 gets launched next week. So happy to have Dr. Goldberg with us tonight, and we'll let him introduce himself here in just a little bit. Before we do that, for those who are watching tonight, there's many ways that you can interact with us. You can view us on Facebook Live or our Periscope live stream. If you have any questions while you're watching those live streams, just go ahead and submit them in the little comment box there, and we'll be monitoring those throughout the show. Or if you're watching on our YouTube live page, you can submit comments there, or you can contact us via Twitter at Carolina WX Group or on our Facebook page. So there's lots of ways tonight to get your questions asked and answered throughout the show. We'll be monitoring those as well. So I think that is all the housekeeping rules before we go live. I will say, if you are listening to our podcast, maybe a couple of days from now or maybe a week from now, we'll let Dr. Goldberg give you all the information about JPSS-1, some websites to follow, maybe a Twitter account to follow. That way you can be up to date and kind of follow along the process as we get this new satellite launched and ready to work for us. So that is the housekeeping rules. We'll quickly go around the panel here to kind of discuss what's been going on in the southeast throughout the past week. No major storm systems. It's just kind of been chilly, and that's chill's been felt everywhere. So we'll start with our far western friend, Mr. Eric, who is in Memphis, Tennessee tonight. Eric, you too have been feeling the big chill, right?
Yeah, it finally cooled down here. We were a degree off a record high last Thursday at 82. Today we sat at 50, 51 degrees under overcast skies all day. And the big news over here in Memphis is that tomorrow we're going to see the sunshine. It's been 9 days since we've had a full day of sun, and so I did go ahead and issue on the behalf of the Memphis area a bright orb warning for tomorrow. Everyone needs to take precautions. Make sure you got your sunglasses, your sunroofs, and carry your pleasant disposition for tomorrow. Looks like we're going to see sunshine all day, and we're definitely looking forward to that. Maybe
you can have lunch outside, because you've not been able to do that the past couple of days, right?
Yeah, exactly.
All right, Eric, thank you for that report from Memphis. Let's go to the sunny coast, but it's not really sunny today. Let's go to Charleston, South Carolina. Jared, you two have been in the cold muck, right?
Yep, no, we are firmly entrenched within the wedge. We set our high temperature at 8:50 this morning at 67 degrees, and it's only been downhill from there. Nice, and now we've got a little bit of cold rain mixing in. My favorite. Said nobody ever. Yesterday, we too were 1 degree off of a record high. It got to 83. Record was 84. We stay chilly over the next few days. Little more rain tomorrow. Peaks of sun occasionally, but the cold air dam is going to hold up quite nicely for us. But on the plus side, it does feel like fall. So there's something to that. So back to you, Scotty.
All right, Jared, thank you for that report. It is cold and clammy as well here in the western part of North Carolina. We've been anywhere between 44 and 46 today. It's not really budged with drizzle and light rain, and we're going to expect more light rain and drizzle tonight into tomorrow. So the wedge game is fully on here in the southeast. So, Shay, I guess I won't let you talk about the wedge because we still have tropics to talk about. It's hard to believe we're rounding the end of this year's tropical season, and it just seems like it will not end. So, Shay, what's the latest on our newest tropical storm?
Yep, we have our 17th named storm of the year. It is November the 8th, so I remind everybody that our hurricane season does not end in the Atlantic Basin until November the 30th. So we have to be mindful that there's still warm water out there. There's still potential for tropical cyclones to develop. And our latest one is Rena. I'm going to go ahead and share the screen here. Let me know when you can see.
Yep, we got it.
You got it. Okay, good. So Rena, very high up in latitude, winds at 50 miles per hour, pressure at 995 millibars. This is estimated using Dvorak technique. This is the highest storm since NOAA in 2001. So this is not a very common thing, actually, but kind of a rarity to have a storm this high up in latitude. If we look at its forward track, looks like it's going to head off to the east-northeast towards the Norwegian Sea, north of Europe in time. It does stay S is its description in the forecast track, but this is really going to become more of an extratropical cyclone here in the next day or two as it moves over cooler waters. These water temperatures really fall off once you get north of 40 degrees north. So pretty impressive little storm. I mean, it's holding together pretty well. You can see here just in the early frames where it's still holding tropical characteristics, but then you get this comma shape to it as it heads off to the north in this final satellite images, and you can see where that cool air is starting to wrap into the center. There's still a little blob of convection on the north and northwestern quadrant, but it will be moving over cooler water, so it will take on extratropical characteristics and slowly fizzle out. So that's all we have right now for the tropics. I think you know, the main thing here is to remember that we've had a hyperactive season this year. We've had a lot of damaging storms. We're on the back end. It looks like things are starting to taper off. But we can't close our eyes just yet. And even beyond November the 30th, we have seen storms form here and there. So we still got to watch the tropics pretty much year round as we end this really active season for 2017. For the Pacific, we're still in a La Nina watch, and we'll continue to watch that. It looks like it may not hit La Nina until maybe late winter or a full La Nina, but we'll see what happens. I think some of the European model was way off on that and some of its forecast predictions a few months ago. So anything could happen between now and then. We're just watching the Pacific waters to see what kind of pattern we're going to get in the southeast for the winter. Back to you, Scotty. All
right, thank you, Shay, for that. And I'll toss it over to James Brierton. I will say Ricky Matthews is off tonight. He was called in to do a little bit of work. So James is going to be handling our interview tonight, James. So I'll give it off to you, and we'll start the show tonight.
I like how you said Ricky is off, which really is just code for Ricky got called into his full-time paying job. So, Ricky, sorry you're not here tonight, but he has passed off some questions for us that we'll be asking along with your questions at home, too. So like Scotty said off the top of the show, be sure to comment with those no matter what platform you're watching on. Briefly, I will share, here in Charlotte, North Carolina today, it was gross, cold and damp, and just in case I needed any reminder of that, my watch has decided that it was not going to even update the temperature today, so it has just been reading 46 on my wrist all day long in case I needed any encouragement to remind me just how cold it was. I think we probably were slightly above that. I think that is a morning temperature. So as Scotty mentioned, we have a great show for you tonight. We're going to be talking about one of the new satellites that will be going up into space, hopefully in a not too distant future, to help with our weather forecasting capabilities. And our guest for tonight is Dr. Mitch Goldberg. He is the program scientist on this JPSS satellite, the Joint Polar Satellite System, if I have my abbreviations correct there, Dr. Goldberg. How are you this evening?
Very good, thank you. Yeah, that's correct. It's a Joint Polar Satellite System.
So what does that mean in layman's terms? I guess if you were to go into a fourth grade classroom, how would you explain that?
Well, I would describe first two different satellites. So one is the geostationary satellite that we're all familiar with because you see that on TV all the time. So that satellite is about 22,300 miles above the equator, and it is moving at the same speed as the Earth is moving. So it looks like it's always staying in one spot, and it's always scanning our part of the world and showing real-time imagery of clouds and things like that. The polar satellite is different. It's in a lower orbit. It orbits about 512 miles above the Earth, and while it's orbiting from pole to pole, the Earth is moving underneath it. And so we get global observations. And these global observations are critical for weather forecast models. So when you see a forecast out to 7 days, which is very common now, the confidence in the 7-day forecast comes from a variety of information. But one of the critical data sets that go into the 7-day forecast, or the 3 to 7 day forecast, is from polar orbiting satellite data.
So this satellite, unlike the traditional ones that Shay was showing us a moment ago when we're looking at the tropics, and that kind of just is parked over the system or the storm, this one is almost doing somersaults essentially over the planet. Is that kind of an accurate way to visualize that?
Yeah, it's moving. You can imagine the satellite always in the same constant orbit, just flying from South Pole to North Pole and keep on orbiting. And while it's orbiting, the Earth is moving underneath it, so it scans the entire planet.
Most of our viewers.
So, for example,
I'm sorry. Go ahead.
No, I was just going to say. So you can imagine, you can have, a typhoon off of Japan, for example, and that typhoon is going to eventually, good chance of affecting weather, let's say in California or Alaska, and so you need to get these global observations. So that's really the main contribution of the polar orbiting satellites, is that it sees the entire planet. So whether that's happening thousands and thousands of miles away will eventually potentially impact our weather, and all that data goes into weather forecast models in order to give us really good forecasts.
And I understand it has several instruments on board, and I should note why I tee up that question that most of our viewers right now joining us online are looking at some computer-generated renderings of this satellite that NOAA has provided, and we can see all sorts of things from solar panels to little satellite arms. But on board there are a number of tool sets, I imagine, that are mission critical to this operation. Can you introduce us to some of those?
Sure. So we have 5 different instruments. And the critical data that goes into forecast models, they actually include atmospheric temperature and water vapor information. So we have 2 instruments. One is a microwave sounder, and I should start by saying that the Earth is constantly emitting energy, and so we observe that energy in different wavelengths. And in the microwave, we get to see through clouds because the size of the wavelength is large compared to the size of water droplets. So we can see through clouds, and we can capture atmospheric temperature and water vapor. But it's also impacted by large water droplets. So when it's raining, we can actually see where it's raining. So it's very similar to radar. Weather radar doesn't exist over the ocean, so we can get precipitation estimates over the ocean from microwave observations. And it's also impacted by, snow cover and sea ice. So because it's a polar orbiting satellite, we see a lot of information, we cover a lot of real estate over the polar region. And so we can monitor, for example, the sea ice cap and how the sea ice is changing. And so there's a lot of applications with the microwave. Then we have an infrared sounder. It has, it sees more vertical information of atmospheric temperature and water vapor. So we can see, it has high vertical resolution, so we see more information in the atmosphere, but it's impacted by clouds, and that's why you need the microwave. So the microwave and infrared sounders, they work in tandem, and they're providing the critical weather, the critical information that feeds the weather forecast models. This 3rd instrument we have is an imager. It's called VIIRS, and that really is our what we call environmental intelligence. So it's looking for features. And so we have a sensor channel that is very sensitive to fires, very small fires. So we can detect very small fires before they become larger. And we've been using our fire product, which not only gives us the location of the fire, but it also gives us how hot the fire is. And that information has been going into this model called the HER model, High Resolution Rapid Refresh. And that's been used over the last couple of years for predicting the forecasting smoke plumes and things like that. We've been using the imager also for a lot of other applications like flood mapping. So after the Hurricane Harvey, when we had a lot of flooding in Texas and also in Florida from Irma, we were able to map where the flooding was occurring. And we actually gave that data to FEMA, and FEMA then used that data to bring in other assets to take a closer look. And we also can look at the ocean color, which is correlated to water quality. And so we can look at harmful algal blooms along the coastline. We can determine areas where there's large sea surface temperature gradients and also large areas of ocean nutrients. And that's very important for stock assessments and fishing. And so it does a lot. We have an instrument that does a lot. I'm seeing an image that you're bringing up. We have a unique sensor or a channel on VIIRS called the day-night band, and we can see basically it's like having a visible channel that works at night. And so we can see clouds at night. We can see cities at night. this channel was very important for a number of applications, but more recently, it was used to show where the power outages were over Florida and also over Puerto Rico. And so there's a lot of applications. And then that's just 3 of the instruments, right? The 4th one is an ozone sounder. I know there's a lot. So we have to monitor ozone. Stratospheric ozone is very important for a lot of applications for radiative information that goes into our forecast models. It's also used to monitor the ozone hole, and it's also used for the input for the UV index. So when you give your 5-day, 7-day forecast, or the next day forecast, I should say, when you give your forecast, like it's going to be sunny tomorrow, the UV index is 8. That information is coming from our ozone sounder. And then finally, we have an instrument called CrIS that gives us information about Earth's energy budget. And that's our lineup. It's like having a baseball team with 5 key players. It's very powerful. We don't need 9 players. We only need 5 because our instrument's very powerful.
I'm really glad you walked us through that. You're right. It is a number of things. I think we're getting some echo at the moment, but I'm going to continue to talk through it. But I'm glad you described it as opposed to me reading it off because, of course, you are the expert on this. And you mentioned, and I'm just reiterating for some of our viewers at home, that satellites allow us to see so much more than what ground-based radar can see. Ground-based radar, of course, is a valuable tool, but it has kind of a limited visibility, and it's almost like we're getting the high ground here on the storms and the weather, if I understand it correctly. And I'm wondering if you can tell us, are anything in the orbit right now? Any other satellites out there performing similar tasks, or is this some really brand new spanking things that are going to be going up here pretty soon?
No, it's so we have a satellite that was launched back in 2011 called SUMI-MPP, and JPSS-1, which becomes NOAA 20, is very similar to SUMI-MPP. There are some differences, but SUMI-MPP was our research mission. It was intended to be like a pathway from NOAA operations of our older satellites called the POST series to JPSS-1. And so that was sort of our transition point. But it has operated so well that we actually made it operational. So SUMI-MPP right now, this moment, it's our primary operation weather satellite from polar orbit. Next week, we'll have JPSS-1. In 90 days after the launch of JPSS-1, it will be checked out, and the data will start flowing to like National Weather Service. And then JPSS will become our primary satellite. And so we'll have 2 satellites in orbit, and that's always been the plan, to have 2 satellites in the same orbit for backup. And it actually, each orbit is about 101 minutes, and so they're separated by 50 minutes. So we'll have twice the amount of data going to models. And also the JPSS segment is a little bit different, and it brings in the data twice as fast as from SUMI-MPP.
Now, I had a question for you concerning the sea surface temperatures. You were talking about the algal blooms and some of the other MODIS imaging that we get. I know that the NOAA 14 and 18s, I think that they had a tough time getting through cloud cover to get sea surface temperatures. So at a higher resolution, is this going to resolve those issues? And if so, how would it get sea surface temperatures through clouding from space?
Well, sea surface temperature, so we have a couple ways. So as I mentioned earlier, we actually at NOAA, we generate a blended sea surface temperature. And so we take information from various sources. So the best spatial resolution, to looking at the sharp gradients will come from VIIRS. It has like 375 meter resolution. So that's important. But you're right. What do you do about clouds? Well, we use a geostationary satellite. The geostationary also can do SST. It's at a coarser resolution, 2 kilometers, but that's okay because at least clouds are moving during the day, right? And so you can do compositing and then you get some information. But sometimes you still have persistent clouds. And so one of our partners, we have a partnership with Japan, JAXA. They have something called AMSTER-2 on GCOM-W, and they have a microwave sensor that can derive sea surface temperature, but it's at a coarser resolution. It's about 10 kilometers. So we blend all that information together, and we come up with one product. And that's how so if you go to the NOAA website and you're looking for sea surface temperature, you'll say, hey, wait a minute, there's no clouds. How are you doing this? So that's why we do that by using different satellites to solve the problem.
That's fascinating. I love Sport SST. NASA Sport SST is a pretty good one, blending there. So.
Oh yeah, they're doing a lot of work. And of course, you mentioned MODIS, and MODIS is a great instrument, but there's no follow-on to MODIS. So VIIRS is basically our nation's, you can call it our operational satellite or sensor on JPSS that will guarantee to have these measurements for the next 20 plus years. So JPSS is a series of satellites, JPS 1, 2, 3, 4, and they're launched about every 5 years, and each one has a 7-year life. So you're not taking any risk. You're reducing the risk of having a gap that you're launching satellites every 5 years, basically.
And that is a perfect lead into my next question, Dr. Goldberg. I know these things take some time to put together, and you're looking to launch this now next week. When did planning start for JPSS-1?
Well, we started planning in the 1990s, late 1990s, because it actually takes about at least 15 good years to build a satellite system, and that's because you got to get everything right. You got to get the user requirements right. So you have to find out exactly what's needed, because you're developing a system that's going to be used 15 years later. So you really have to have a window into the future of what type of services are needed, what type of spatial resolution, things like that. So we work hard on that, working with our customers and asking them questions, getting feedback. So we put that together. Then you have to do some what technology will work, what doesn't work, and so you keep on doing that. And then you'd say, okay, now you're going to start building mass production, because you're not just going to build one, you're going to build more than one, 2, 3, 4 of these units. And that takes a long time, because you have to have everything right. There's no service station in space, right? A satellite is there for like 7 years, at least in terms of design life, and you got to get everything right, and that's why it takes us a long time. So this program actually started a while ago under something called NPOS, and it was a program that that was modified later and was called JPSS. That was focused on NOAA user requirements. So we've been working on this for a while. SUMI MPP was our bridge into the future, bridge mission, and so JPSS-1 will be launched next week. But it does take that long, and it's comparable to other missions. Like, for example, GOES-R, or GOES-16 now, which was launched last year. That planning started about 2002, 2003. So that's also another 15 years. So it takes a long time, because you got to get everything right, and you just can't take chances.
That is just absolutely amazing. I just did some quick Googling for a little comparison to bring us back to 2002. That is the year that Firefly debuted on television, and The Wire, and Monk, and CSI Miami. So if you're watching tonight trying to remember how long ago 2002 was, that's how long you guys have been working on this. How do you try to predict the future? I mean, when you think about 2002, even just consumer technology has come a long way, and I imagine there must be points in your project where you go back and you say, well, now we have this new thing, how can we update our plans for the satellite?
Yeah, well, you have to really think about what type of data is needed. So you pretty much know the spatial resolution models, information like I still need to provide observations of atmospheric temperature and water vapor, and so there are limiting factors. A lot of times it's the spatial resolution, and most of the time it's the spatial resolution and the signal to noise. So we get it, we get to the point where we almost can predict how the models will evolve. And what we've done is we built a really flexible ground system that allows us to almost control the latency. It takes time to get the data, to process the data from the satellite to the ground. And we actually came up with a nice design that as in the future, let's say 10 years from now, weather models, instead of waiting, let's say plus or minus 2 hours to collect the data, let's say they change it to plus or minus 20 minutes. We can actually modify the latency on the ground segment to bring down the data faster. So again, it's pretty advanced technology, and we try to basically predict, how the spatial resolution is going to evolve over time, and it turns out to be pretty good. We have, for example, the NASA VIIRS satellite, NASA Aqua. You're familiar with NASA Aqua Modus. Is something called NASA VIIRS, the atmospheric infrared sounder. That was launched in 2002. That was probably designed in the 1990s. but that's still a hyperspectral infrared sounder. So it still can get high vertical resolution in the atmosphere, and that still has really big impacts on weather forecasting. So there are fundamental measurements that just have a long staying power. And so we're going to be very relevant even for the next 20 years. Yeah, I have confidence in that.
I think Scotty from our panel has a group, so I will toss the mic over to him. You're on mute.
Yeah,
Scotty.
we had posted this into several groups about our show tonight. Now, one of our viewers sent a question to me, Bill Ballantyne. He was wanting to know if you could go into a little bit more detail how this will help us with our weather forecasting, especially the daily model runs that us meteorologists look at day in and day out. How will this satellite help us get maybe even better data and to help forecast?
Well, if you look at the history, so if it would be great if you could bring up a chart of like how the forecast has improved over time. ECMWF, the European models. ECMWF, which is the European Center for Medium Range Weather Forecasting, they have a nice chart on that. But the weather forecasts have really improved over time considerably. I mean, back in 2000, the accuracy of the 3-day forecast has been, in the last 15 years, has been extended to the 5-day forecast. I mean, I don't think back in 2000, did you show 7-day forecasts? Probably not. And the big changing point, that the game changer back then, was the first advanced microwave sounder on our POSE satellites in 1998. And then we had the hyperspectral infrared sounder, called VIIRS. And then later on, the Europeans had their own hyperspectral infrared sounder. And then suddenly we had more satellites with our NOAA series, European series, NASA series. And when you look at, why this forecast improved significantly over time, was a combination of models got better, but it was also the satellite data got better. And so when people, did studies like which data types impact the weather the most, it was always the microwave and infrared sounders, because they're giving you the best information in terms of coverage as well as vertical information. And so we know that. And so what we're doing is a couple things. So we're guaranteeing that we have those type of observations for the next 20 years and more. And so our older POSE operational weather satellites did not have a hyperspectral infrared sounder. It had a microwave sounder, which was pretty good, but this microwave sounder that we have on JPSS is even a lot better. It has better geographic coverage. There's no gaps between the orbits. So we know, we have confidence that this data will continue to improve the weather forecast. And also, when you look at the weather forecast models, because there are limitations of computer time and things like that, not all the information is being used right now in the model. And so when computer power gets strong, more powerful, and we can crunch more numbers, more of our data will actually be used more effectively. So this is why we know it's going to improve the forecast, or continue to improve the forecast, because the accuracy of the incredible improvement in the forecast over the last 17 years was the result of the type of data that JPSS will be providing well into the future as part of an operational mission with a very high reliability.
Shay, I think, has a question as well, so let's go down to Charleston and toss the mic over to Shay.
Yes, I wanted to ask, one of the fascinating features that is on this satellite, one thing I'll be watching for sure, is the ozone. So talk a little bit about the ozone science behind the satellite. What should we expect from this particular orbit, from this one? I think it's satellite number 4, you said?
Satellite, you mean JPSS-1? Yeah. So JPSS-1 and SUMI NPP and other polar satellites, it basically, we use the UV. So we measure outgoing radiation in UV. UV absorbs ozone, and so we look at the UV, and that gives us basically what the concentration of ozone is. And so that's how that works. And so we get very good information on ozone as a function of altitude, and so we can look at things like the ozone hole. So you've probably seen charts of the ozone hole over time, and there's a whole series. There's instruments from OMI that flies on a NASA satellite, and even SBUV, which is on a NOAA satellite of POSE. There's a whole series, a record that goes back to the 1970s, and we can see how the ozone hole actually got larger, and now it's getting a little bit smaller because it's recovered. And so, and that's really important. And it's not just measuring ozone. Ozone is also, the UV is very sensitive to aerosols and SO2. So we can monitor volcanic eruptions very clearly. The signal of the ash from a cloud is clearly separated from normal clouds. So it just highlights the ash and also SO2. So there's a lot of applications. And also, you can actually see power plant emissions of NOxes. So we can actually monitor air quality with our ozone sounder as well.
So it sounds to me, Dr. Goldberg, like this satellite can really see down to the local level if it is seeing things like emission from a power plant. You mentioned fires before too. Is there kind of an emergency first response use to this as well too, where if you spot say a forest fire that no one's aware of yet, the Forest Service might get a call?
Yeah, actually. So we have services within NOAA that looks at the data, interrogates the data, and actually sends out bulletins that for early detection of fires. And remember, these are global measurements, so we're always getting there's something called the International Charter for Disasters, and so there could be a flooding event and a volcanic alert, and so we'll get those messages and we'll send out reports to the international community as well.
That is quite fascinating. Let's go over to Memphis, Tennessee. Our own panelist Eric has a question for you.
All right, thanks a lot. Very interesting stuff, Dr. Goldberg. So I have a keen interest in the aviation side as well, and in technology that can assist in forecasting for aviation purposes. So obviously volcanic ash is a significant hazard, and this sounds like this would definitely assist in that area. Are there other specific applications that JPSS will provide specifically to the aviation community that can help in forecasting or at least monitoring current trends and so forth?
Yeah, there's actually there's something called cold air loft. And so when you have high-flying planes, like a lot of planes going to Asia, for example, they all fly over Alaska at high altitudes, and you can actually fly into a cold pocket. And what happens if it gets too cold? I think it's like less than minus 65 degrees centigrade. The jet fuel will start to gel, and right. So that information is being provided too. That turned out to be very valuable information for forecasters, especially up in Alaska, and for other aviation like clouds and dust and volcanic eruptions. Again, it's an integrated type of information that we provide. So we'll integrate geostationary and polar data. So geostationary is very good. It constantly sees our part of the world, and there's other geostationary satellites. And so that will provide that information. But then when you get into higher altitudes, the spatial resolution of the geostationary degrades. So in the northern latitudes, where there's a lot of aviation in the northern latitudes, that's where JPSS will provide critical information. Volcanic eruptions, ash, and other visibility, poor visibility due to smoke. You can have a fire out in Siberia impacting visibility over our part of the world. So that's why the global nature of JPSS is really important.
So I'll follow up on that, the global nature of that again. Since it is obviously a U.S. satellite, we're using the data here, but it's got global coverage. Are there other agencies, med agencies around the world and so forth that are either contracted to be able to use the data, or that you know of that are using it for applications elsewhere?
Oh, everyone. So every country that has a weather service, Europeans, Japanese, Korea, Australia, they all use our data. Our data, back in the history of polar satellites, it wasn't until 2005 when the Europeans had their own. So the U.S. always led the area of weather satellites from the very beginning, especially, and so we always made sure our data was open and free. And so it's very easy to get our data. If you're a power user, they just subscribe to it and they get it in real time. If you're a researcher, you can go to our archive and get the data. If you're really interested in data in real time and you're a regional user, you can buy your own satellite dish and the data is transmitted constantly every time, anywhere it flies. So we make sure that that we provide the data with very easy access. And at the same time, the Europeans, which I mentioned, also have their own polar satellites. It was launched back in 2005, and we get that data free as well. And actually, there's something called JPS. It's a Joint Polar Satellite Agreement, and and part of JPS includes JPS NOAA, you can call it, and that's what we also call JPSS. But there's also JPS Europe, and the Europeans basically fly the mid-morning. So we orbit around 1:30 in the afternoon. So the satellite passes anywhere in the globe at the equator about 1:30 in the afternoon and 1:30 at night on the other side. And so over the U.S., we get a pass around about 1:45 in the afternoon locally, 2:45 during the summer because of daylight saving time. And the Europeans, they fly satellite 9:30 in the morning. And so we use both data sets. And so both of our agencies, European agencies, U.S. agencies, and also international agencies, we all use weather satellites, and they're all open and free and available to anyone.
That is some
Thanks.
Fabulous data sharing that is available to scientists and the rest of us as well too. And I know the next big milestone for you, Dr. Goldberg, is going to be getting this thing up into orbit. I understand there was a delay in the launch earlier in the week due to the a faulty battery, and you have another launch window coming up. What is that launch window that we should all be watching for?
Well, that's going to be November 14th. 1:47 in the morning Pacific time. So people on the East Coast wake up at 4:47, or no, before that, you don't want to miss it. So wake up around 4:30 if you're on the East Coast, and turn on NASA TV. And also you can get more information on our NOAA satellites. We have a Twitter feed.
Fabulous.
At NOAA Satellite. At NOAA Satellites. And we have a JPS website, which I see you have on the screen now. And it gives you all this information.
James, I've got a quick kind of question from one of our viewers, kind of in this topic. Dr. Goldberg, this from Jill. She's watching tonight. And she wanted to know, you've put so much preparation into this. What are your thoughts? Are you nervous about anything? Just what are your thoughts going into this week of launch? I mean, what are your expectations? Obviously we want a perfect launch, but any nervous or anything nervous, or how are your feelings going into this week?
Well, you always get butterflies, little flutters, when you're launching a new satellite, you want it to be successful. So I'm always optimistic, so I'm planning for success. And so we're going to get out there, and that rocket's going to take off, and knock on wood, it's going to be successful launch. And we're excited because we're really ready for this, because SUMI MPP, which again is our mid-bridge mission, has been so successful. All the instruments are working well. It has provided great value. I gave certain examples of how we've been using it for fire detection already, and flood mapping, and both the sounders, the ATMS and the CrIS, has been having huge impacts in weather forecasting. And so we expect to see the same, and now we're going to have twice the amount of data, better coverage. And so I'm really excited. I'm really excited, and I expect success. I anticipate a successful mission. You don't want to say too much, because you don't want to just knock on wood, right? We're all superstitious, right?
That's right. We know everything is going to go great, and we can't wait to see the data.
Yeah, so we're excited. It's been a long time, and again, this is our first operational class mission. SUMI MPP again was our research mission, and this one is more rigorous and has a 7-year design life. So we can't wait for this to happen. And again, we'll have 2 satellites in orbit and twice the amount of data and things like that.
That's going to be fantastic. So you mentioned, sorry, James, go ahead.
No, you go ahead, Shay.
Oh, okay. I was just going to ask, you mentioned earlier in the show about it being roughly 90 days. So I guess I want to kind of circle back to that and ask the data that's going to start coming in, is it going to be 90 days, maybe a little bit before? And is that going to be preliminary, non-operational data, sort of like GOES is going through right now?
Yeah. So we have to test the data out. So everything is tested and reviewed, and so we expect that before within the 90 days, of course, we're going to see data for the first time. They won't be publicly released because we have to verify, validate the data, and then we hope that L+90 will be distributing the data to Weather Service, and they'll be providing feedback, and then hopefully we'll declare it operational. But we don't declare anything operational until everything has been verified. So it takes a little bit of time, but it's worth it because you don't want to send bad data to the public, because there's always these lookup tables, things like that, nerdy things that you have to make sure that that all the data sets are properly characterized. So there's a lot of work that we have to do.
Our fellow panelist, Ricky Matthews, who's not with us tonight, is a broadcast Met, and I think he is hoping, and I'm not sure if you're able to shine light on this, but is this data that maybe one day we'll be seeing on local television fed through to the local meteorologist there so that they can share with the public that way as well?
Yeah, sure. I mean, we have great imagery, so there's certainly events that you would like to see. So we hope the data is available. I mean, we have images that we can provide through our websites. I think one of the products that you'll really like, because I know you're used to looking at water vapor imagery from geostationary, and one of the key products that we have for forecasters is total precipitable water from the microwave. And you probably have looked at blended total precipitable water right from a microwave, and of course you can see through clouds, so it doesn't. So sometimes, for example, if you look at a geostationary water vapor loop, you'll see water vapor at an upper level, but in the lower level, water vapor will be coming from a different direction. But you can't. It's hard to see that in the infrared, but the microwave you'll be able to see that. So I hope that somehow the weather vendors will provide microwave imagery as routine, because I think you'll find that very valuable. Hurricane Irma, yeah, it was Irma. You could see the fetch of moisture all the way from Panama, just not being, disguised or covered. Oh, here you go. You're looking at something there. Yes, the morph composite. Very nice. So perfect timing. You set me up. I mean, so you can see the plumes of moisture, and for Irma, we could see a plume of moisture coming all the way from Panama, and it looked like it was actually jumping over Panama from the Pacific, and it fed right into the storm when Miami was getting all that heavy rain. I could see that plume into Irma, and that's what the microwave really offers you. You're going to be able to see moisture plumes, and also we can do it at different levels too. What you're looking is at total precipitable water, but we can look at low level, mid level, upper level, and I think that you're going to find that very valuable. And this is our old product. We have a new one that actually the plumes continue over land, so you don't have that ocean-only viewpoint. We actually have a nice product over land. Actually, if you Google, this is all live, right? So if you go on the internet and you type in SIMS TPW2 mimic, you'll see great imagery of microwave TPW over ocean and land. So it's called TPW2 mimic, and if you Google that, you'll find it right away.
I see Shay's fingers immediately going and typing there as he pulled up that last.
Yeah, so I'm pulling it up. I mean, that's something I use for the tropics year-round right there. That's a great product. This one just became operational over land, I think, last year. I see it. I see it there. There you go. Now, this is the value of polar satellite. So what it's doing is it's taking data from multiple orbits. So it's not just, let's say the early afternoon orbit. It's taking data from the U.S. satellites and the European satellites, and we get all that data as fast as our data. So we have this agreement. So we just get that data, and then we're morphing that with the forecast. So the forecast is pretty good in predicting, wind advection, and moisture travels really nicely with the wind. So we're morphing that, and then we get an image like that that's updated every hour. It's a blended product of polar satellites, microwave, total precipitable water, along with the forecast to get that fluid motion. And I think that's your go-to. I mean, if you only could pick one product that you would show every day on TV, it would be the one. You could see, look at that that atmospheric river curving and hitting California.
It's just an incredible, and you can see the waves. And there was a nice, a couple of weeks ago when we had that big typhoon off of Japan. You can see that moisture plume going all the way across the Pacific, hitting California.
Yeah,
or Seattle.
That's exactly right. Yeah, I love this product because it definitely shows you the teleconnection from the Western Pacific all the way across the North Pacific jet and all the way into the United States, and you can watch that energy transfer from one side of the world to the other. It's beautiful.
So that's a nice example of polar satellites, and then imagery. So, and also you're going to have episodic events. So, like for example, if there's a power outage, you're going to want to show images from our satellite showing where the lights are out. Or even if you have a major drought, for example, we have a product called Vegetation Health. It actually shows the health of the vegetation, and it's colored so that if it's really red, that means the vegetation is really stressful. And so, and I'm sure I heard earlier that you got a lot of rain in the southeast, so that vegetation is very vibrant. So you can actually see on a global scale the health of vegetation. And every now and then, if you have a news story about showing the health of the vegetation of the drought, satellite data, and show images from that. Also, if you're showing interest stories about, let's say, the Northwest Passage, and showing where if the Northwest Passage is clear of ice or not, you would basically maybe do a feature on that. And also small fires. We can detect fires at night just by the light of the fires. So if there's a big fire, situation like the Napa Valley, you didn't show that on TV, did you? No, but Napa Valley, you could see Napa Valley with the lights from the, you could see the city lights, and then you could see all these big lights just coming from fires. That would have been impressive to show on TV. So yes, there's a place for polar satellite data on your weather forecasts, but you don't have to show it every day, except for the microwave. But for other things, you want to show it when you have these big episodic events.
And I think University of Wisconsin-Madison does a great job at relaying that. But I think Eric had a question.
Yeah, just one last follow-up. You talked about one of the benefits of having the dual satellites up there once this one gets into orbit. So since the Suomi NPP has already kind of passed its, I guess, expected life scale, what is the future for that? Are you just going to let that continue to run until it can't run anymore? Or
yeah, absolutely. And so we it has enough fuel to last until the 2020s. And that won't be an issue. And so we plan to operate Suomi NPP and JPSS 1020 for a while. Then we're going to have then we'll have JPSS 2, and so potentially we'll have 3. But then we can adjust the orbits a little bit, so they're not lying on top of each other. So maybe in the future, I can imagine maybe moving Suomi NPP in a 230 orbit. That's possible, but we'll see. We hopefully all these satellites will last for a long time. The longer they last, the more data we get, and the better temporal coverage. So we hope for the best. But yeah, Suomi NPP, there's high expectation that Suomi NPP will keep on working until like 2027 or 2028. Then there'll be a time that we're trying to minimize space junk, and so in the old days you can launch satellites and they'll just drift over time, and 40 years later they'll burn up. But during that time you can have space debris, and you could you get a traffic jam in space. It's not that bad, but you don't need Google Maps up there. But so what we do now is that the space policy that says you have to have enough fuel to safely deorbit the satellite. So so it's not going to last. It's not going to be up there until like the 2030s or 40s, because we have to safely bring it down. So.
Wow, never thought there'd be an ordinance for burning up satellites.
Well, it has to be. They get too much space junk. Sometimes a satellite, when they get old, can just simply like explode, and you get all these particles. I mean, we have to monitor space debris all the time. Sometimes we have to maneuver our satellite. Like we'll get an emergency, like a message saying space debris upcoming, let's say tomorrow, and because NASA and the Air Force, they monitor this very closely. And so we'll get reports, and then we'll have to maneuver the satellite a bit to make sure we pass the way, so we don't go through space debris and get it back. So space debris is a big issue, and so we can't just leave satellites up there forever. We have to bring them down safely after its time.
That sounds like another show we could have. You know, the space debris and satellites.
Those things, I mean, you got bolts flying at 25,000 miles an hour. I mean, they're going to put holes through things, and I've seen things riddled with holes in it up there in pictures. Wow. I mean, just
the movie Gravity, right?
Debris. Yeah.
The Gravity movie was interesting. That was a satellite exploded or something like that, and all the space debris, and it knocked out the whole world.
I was gonna say it all sounds like a sci-fi thriller, and I guess a little bit it is. But we're thankful for all the people who are keeping an eye on those things, so we can get weather imagery and also keep our satellite televisions working.
Yeah, I can tell you one cool thing that you probably that I didn't tell before. So it's so we have the VIIRS images very sensitive to light, and there's a crabbing vessel. I think it was in the Dangerous Catch on what is it, Discovery Channel? Something has I forgot the network, but the vessel called the Kiska, it was actually lost. It was stuck in the ice pack, like it couldn't figure out where it was to get out, and so the Coast Guard called the Weather Service and said, "Hey, can you help us figure this out?" And they looked at the day-night band that is very sensitive to light, and they could see the light from the ship. We were able to see it. Of course, we had the GPS coordinates, so we knew where to look. But the thing about it is that we could also see the ice at night, and so we were able to say, go straight, make a right, make a left, to get out of the ice pack. So that was really interesting. So that was a good, that was a great event. We were able to help this ship to find its way, because when you look at the image, you'll see the rest of the crabbing vessel, maybe like 20 boats in this one area, and this one boat, maybe he was trying to get better crab somewhere, but it was just by itself and stuck in the ice. And so that's a good story of our satellite technology can detect lights in different parts of the world.
Wow, speaking of lights, up north, what about the Aurora Borealis? Would it be able to catch that?
Oh, absolutely. Just do a Google search, say VIIRS, VIIRS, and Google search that, and you'll find images all over the place. It's beautiful imagery.
And while
it's beautiful.
Shay looks to bring that up, I'm going to let our panelists know that in the next few minutes here, as we come up to about 9:07 p.m. Eastern Time, looking ahead to share everyone's tweet of the week. And Dr. Goldberg, I don't know if you have anything you'd like to share, but in a moment we are going to take a kind of lighthearted tour around the panel and just share some multimedia that we saw this week. It could be weather related, science related. It's just a nice way to end our show, or as they like to call it in broadcast, a kicker. So we'll be doing that in just a second. But before we transition over to that, I want to give you a chance again to share any personal Twitter handles or social media handles you might have, if folks can reach out to you. Or I know you said NOAA Satellites has their own Twitter handle, so if anyone is watching or listening to our rebroadcast, how can they learn more about the program? And I will double load that with your commentary, if I may request it, over the image that Shay has now pulled up as well too.
Yeah, so here you see the lights, and it's clear. So that's very important. It's beautiful, but it's also important for satellite communications, radio communications. And then below that, this is, I guess, the middle of Canada. And then below that, you can see the beautiful city lights. Every town, you can see highways. You can see just the features. You can see the low clouds. You can see areas of fog as well. That's also amazing to look at. But yeah, we have a great instrument that can detect lights. Again, we can actually see boats in addition, and actually lava in a volcano we can see from our sensor.
That is certainly quite impressive. And listening to that boat story before, I wish I could call them up next time I'm stuck in traffic and ask them for the quickest way out, because we have
different technology for that. Those are called Google Maps. But anyway,
yes.
It's,
and what do we have here, or Shay or Dr. Goldberg? What type of imagery do we have popped up on the screen?
It's the same image before, so we're looking at a different area.
Yeah,
but,
this is 12Z. This is this morning. I've got the live NPP data from whatever that goes over the Wisconsin broadcast, I think. And I feel like maybe I've got a little bit of aurora action going on just in this little slice right here from last night.
Yeah, and let's see if we can see any ice too. Any ice?
I see some snowpack there on the ground.
Mm-hmm.
Yeah, and it should render when you zoom in. Yep, it's rendering. Yeah, so that's why you know, the most important is the ice applications up there. There's a lot of navigation that takes place.
Mm-hmm.
You know, it's funny. Another story I could tell you was, you know, there's this Crystal Serenity. I think the name of the ship. You know, they go from Anchorage through the Northwest Passage to New York City, and so I was looking at the imagery, and last year in 2016 they had no issues. I said, you know, I was curious, and I said, let me look at the imagery, and you know, we have high resolution, and I said, yeah, no problem. You know, they shouldn't have an issue at all getting through the Northwest Passage. And then this year, I noticed that there was a little bit more ice, and so I called up Weather Service and I said, they've been asking for any information, and they said, nah, they haven't really been communicating with us. I said, okay, fine. And then after the vessel got to New York, I said, well, I guess they had no problems. But then I was looking at their log, and they have pictures and logs every day. And the place where I thought they were having problems, they actually had a problem. They said, oh, we had to call in the Canadian Coast Guards to break up the ice for us. So anyway, so ice monitoring from polar satellites with a combination of the high spatial resolution imagery that we get from VIIRS plus the day-night band from VIIRS that can see ice at night, that's going to be really important when we have more navigation up near the poles.
That is. I'm looking forward to so much of that, and I know you said that the launch you will have here for JPSS 1 on November the 14th, early in the morning, is something that has been in the work for some 15 years. Really looking forward to that, and I can't imagine what you guys have in the work for 15 more years down the road. Looking forward to all of that. Dr. Mitch Goldberg, thank you so much for your time tonight. A wealth of information, and hopefully you'll be able to come back after the launch, and after you've got those images publishing out there, we'd love to take a look at them with you.
Thank you for having me. It's great. I had a great time. Thank you.
Oh, you're absolutely welcome. Thank you for your time. You're welcome to stick around here as we wrap up tonight's show to do Tweet of the Week. I'll hand things over to Scotty Powell for his tweet, and then allow him to tour us through the Carolina Weather Group panel. Scotty?
All right. Let me get mine loaded right quick. Where's it at? Oh, there it is. All right. All right. You guys ready? Can you see mine?
Pull it up, Scotty. I'll share it out.
You got mine?
Yeah,
Yep,
we got you, Scott.
we
What
got
are we
you.
looking at here?
So we've been talking about how crazy the tropics has been with hurricanes, but also it's been pretty common with tornadoes as well. This is the fourth highest amount of tornadoes, 119 preliminary tornadoes with tropical cyclones this year. The only other years that has beat 2017 would be 2008, and then the mega years of 2004 and 2005. But again, tornadoes really piling up with the tornado with the hurricanes. And as you can see here, the Storm Prediction Center has put together this graphic here. Hurricane Irma with 25 tornadoes, Nate with 16, Harvey with 57, and Cindy with 18 tornadoes. So again, not only has the hurricane season been big stories with the storm surge and landfall and hurricanes, but also tornadoes. So again, 119 produced from landfall and tropical cyclones this year in the United States. So that is my tweet of the week. And I will, let's toss it to Jared because he's the one that I see next to me. Jared, have you got your tweet of the week ready?
You had my tweet of the week, so I'm working on that.
Oh no, I stole it. All right, let's go to Eric. Eric, do you have yours?
Okay, yeah, I'm going on the very light side tonight. We're going to get away from all this weather geeky, nerdy stuff that we've been talking about and go light. Last night was the inception of the 280 character tweets. There was lots of cool stuff that people were posting about what they could get in 280 tweets, but I got to go with my sweet tooth tonight to Cookie Monster tweeting, He has 280 cookies spelling out the word cookie. There's the best 280 character tweet I've seen. There was a lot of
I've got a contender for you, Eric. I'm going to go head to head on with you on that topic.
Let's go.
All right, James, do you have yours ready?
I do, and it is right on cue for tonight's conversation from NASA Goddard. Thanks, Twitter. We could always use more space, and it's got a bunch of emojis. Let me pop this back up for you watching on YouTube. Hang on, real fast here.
I saw that earlier.
I thought that was kind of right on cue for tonight. I've got too many monitors going here, but I'm going to bring it up for you in just a moment here. And there it is. So you can see that as well too. Speaking of satellites and speaking of space, right on cue with 280 characters this week on Twitter. Look for some longer rants coming from us here at the Carolina Weather Group.
I've never seen those emojis before.
You got to get with it, man. All the hip, cool kids are using these emojis nowadays.
I'm going to have to find those. Pretty cool.
It must be their verified account. That's got to be what it is, right?
It has to be.
Yes, we got to have one for Cinnabon, too.
That's right. We haven't got our weekly Cinnabon in. So, Cinnabon, again, thank you for everything you do for us here at the Carolina Weather Group. Shay, how about you?
What do they do for us here at the Carolina Weather Group?
They like our tweets. That's about it. But
if somebody's getting a paycheck from Cinnabon, it's news to me. Shay, I'm sorry.
No, it's fine. Let's see. My tweet of the week just came in today, actually, and one of the National Weather Service gentlemen posted on his Facebook page, but I figured I'd just go right to the site here for NOAA. Contiguous United States has the third warmest January third warmest year, January to October on record. And if you see here, the Southeast, lots of the Southeast here showing record warm temperatures for the year. So it looks like we're going to end up 2017 record warm year for us, this coming after last year. So I mean, we're kind of on that same track. So that's my tweet of the week, just showing the warmth, the absolute warmth that we've had this year in the Southeast region, parts of Texas, and even parts of the West. But I mean, we've felt it here in Charleston. There's no doubt about it. Just how long the heat was here in the Charleston area, at least. I mean, I know that we broke records regularly here for continuous temperatures above 90 degrees, for instance, was one of them. So,
see, that might be a good stat for Jared, and I'll look into it as well. Maybe next week we can talk about how many days above. I mean, 90 degrees is sometimes typical in the Southeast, but 80 degrees really, I would say since April through October, we've had a good amount of days above 80 degrees, or maybe even 85. So that would be probably a good stat. Maybe it blow us away of how many days we've had this year.
First 5 to 7 days in this month of November. Yeah, it was. First 5 to 7 days in this month of November was over 80. All right, so we're gonna do a self-serving tweet of the week. This is from my own account. I apologize for nothing. But this is a good look at the wedge building in on 16 5-minute imagery preliminary non-operational known to cause cancer in California. You can see you see a lot of overrunning there, but you can if you look real close over South Carolina, you can see that wedge front steadily sinking south with the nice icky stratus. Oh, lots of IFR today for you aviation geeks out there. Just a very IFR, just gnarly, nasty, icky fall day that, I'm just not a fan of, quite frankly. But the wedge is interesting. So that's my tweet of the week, largely self-serving. Back to you, Scotty.
Sorry, Jared. I didn't mean to steal your tweet earlier. My bad.
That's okay.
All right. Well, that is all of the tweets of the weeks. Again, let me pull up the schedule right quick. We'll briefly go over what's coming up here in the next few weeks. Next week, we're going to be talking to Miss Diane Thomas. She works for the North Carolina Emergency Management. She's a meteorologist for those folks there in Raleigh. She'll be joining us as well as John Q from the National.
I'm sorry, John Q.
John Q from the National Weather Service in Columbia, South Carolina. He's going to be joining us as well. We're going to kind of talk about how the states work hand in hand with the National Weather Service getting ready for big time events, and then how we do during the event and then even after the event. So interesting show next week. And then after that, we have Jamie Morrow possibly. I know that Ricky said that he may be in question because he's moving to the Raleigh office. So Jamie may be on with us talking about the National NWS Weather Event Simulator. And then as we round out the month of November, I'll let Shay Gibson tell us what we have in store for November 29th.
Well, we have Jim Cantori joining us to discuss the 2017 hurricane season. So lots to talk about there. And still got to do a just kind of a pre-test check with him. But we're looking forward to having Jim Cantori on. First time for him being on here. We've had other individuals from the Weather Channel come on. So this will be an exciting first time for us to have the man on.
That's right. We're looking forward to Jim. It's been a crazy 2017 hurricane season, and Jim, quite frankly, has been out in the middle of all of them. So he'll give us the latest and his thoughts as we recap the 2017 Atlantic tropical season. Guys, that's all I have. Anybody else have anything before we log off tonight? I hear silence, so I guess not. Thanks to everyone for watching tonight, the Carolina Weather Group. Remember to share us with your friends and family, and make sure they're following us on our social media accounts or following us on our podcast. We'll get these podcasts updated, and you can always follow along on our YouTube live page as well. We hope that you have a great weekend. Stay warm out there because the big cool down is coming, and we will see you next Wednesday night here for another episode of the Carolina Weather.